Anyway, I'll give you a list of definitions just so that we have a clear idea. Okay, we all know what is a substring. Okay, and you just pick some contiguous set of positions in the middle of a string, and you call that a substring, right? So you have the notation we are going to use is the usual array notation for strings. So you have a string S which has I characters starting from 1 to I, right? So it's an array, and we talk about a string P being a substring of a string S if P1 to J match S of L plus 1 to L plus J. Okay, so that means you have a match. The P is a substring of S starting at the L plus 1 positions starting at the L plus 1 position. Prefix, well, prefix is a special case of a substring which occurs at the beginning of the string, and similarly suffix is another special case that ends at the end of the bigger string. Okay, and a subsequence is something that we have already talked about when we discussed edit distance, and so that doesn't have to be described again. So if you take BCD, BCD is a substring of ABCDE starting at position 2, right? So it's a substring starting at position 2. DE is a suffix because this E is going to end at the end of the bigger string, so it's a suffix. And ABCD is a prefix because it's a substring that starts at the beginning of the string. Okay? And ACD is a subsequence because it doesn't occur, the characters in ACD don't occur contiguously in the bigger string, right? So it's a subsequence. So typically, generally speaking, we are not going to talk about subsequences anymore in this series of lectures. We are only going to talk about problems like suffixes and prefixes and substrings. Okay? And we use the term proper to say, okay, if something is a proper substring, means that the two are not equal. Okay? So S is always a substring of S itself, but then we won't call that a proper substring. The proper substring is one which actually is not equal to the other string. Okay, and in string matching, we often use the terminology of a pattern and a string. Okay, another string which might be called as text or subject or by various other terms. Okay, the distinguished string is a pattern, and the other one is given multiple names. Okay, so there are several problems that you can pose involving two strings. In one case, you can say, is there an exact match? Okay, and that might ask whether P is a substring of S. Okay, so it's an exact match. And then you might say match with wildcards. In this case, the pattern can contain wildcard characters. Okay, that means a wildcard means it can match any character. Okay, but it doesn't mean match a sequence of characters. Okay, so that's the more general case of a pattern is a regular expression. Okay, and other flavors of the problem involve finding substrings, prefixes, and approximate matches, and problem of multi-match, where you have a set of patterns and then you want to find if any of them match. Okay. So what we are going to do really is we are going to start off by talking about algorithms for matching regular expressions, because those are the most general. That's the most general case, and then from there, what we are going to do is we are going to, again, start from the general algorithm and special case it for various problems. Okay, once again, we are going to use the same approach we have used in the past, several times in the past, which is to start with the general algorithm, see how that can be used to solve special cases, and then by observing how that algorithm works, then we kind of rework the algorithm to make it more efficient, simpler, and so on. Okay, so that's what we're going to do here also. Okay, so let me not go into this, and let's talk about regular expressions. Okay, I'm assuming that almost every one of you know what a regular expression is. So I will go through some of the definitions, but on the other hand, I'm not going to spend a lot of time because it should be a familiar topic. Okay, so you define a regular expression in terms of the base cases. The base cases are the empty string, right? A string that has a length of 0, has no characters, and then unit strings which consist of a single character. Okay, so these are the base cases, right? And we talk about an alphabet. Whenever we talk about problems involving strings, we always talk about an alphabet, right? The characters in the string are drawn from an alphabet. Okay, and what we are saying here is that the empty string is a regular expression, and then we are saying that every alphabet character is by itself a regular expression. Okay, and then we have the real regular expression operators, which are concatenation, alternation, and closure. Right? So concatenation means you just put them together. So if R1 and R2 are regular expressions, then you can inductively build larger regular expressions by applying these operators. Right? So one of the operators is concatenation, and presumably we all understand what that is. Alternative, which says you match either R1 or R2, and closure, which matches 0 or more repetitions of that particular regular expression. Okay, so some examples. So if you say A, okay, once again, we assume in this case that the alphabet consists of 2 characters A and B. Okay, and if you just write A, then it just matches a single string A. Okay, and A or B means you can match one of 2 strings. Okay, A and B. And if you think of regular expressions in terms of the set of strings that they match, then alternation operator is exactly equivalent to set union operation. Okay, so similarly, concatenation actually corresponds to a product operation on sets. Okay, and closure is something that again we understand. So let's look at examples. So A or B star, well, because it's a star, it can always match the empty string. So one of the instances that's going to match A or B star is epsilon. Okay, and then you repeat what is inside the star once. Okay, and that is A or B, and therefore the strings that match will be both A and B. Okay, and then you repeat this. What is inside the star 2 times? That will give you AA or AB or BA or BB. Right? So there are 4 strings of that length, and then you can repeat it 3 times and so on. Okay? So there are obviously an infinite number of strings that will match this regular expression. Okay? So if you say A star, B star, well, that's another set, and what you will find. If you think about it, is that the difference between the first case and the second case is that in the case of A star, B star, you have all A's occurring before all B's, right? Both of them represent infinite sets, but in the second case, all A's must appear before all B's, whereas in the first case, any sequence of A's and B's is acceptable. Okay? However, if you put another star outside, then you can see that now A's don't have to appear before B's, right? And you can repeat A's and B's in any alternate in any fashion between A's and B's. In this case of A star, B star, whole star, right? Because you can do this. So obviously, if you have A star, B star, whole star, right? So it's going to repeat this as many times as you want. And each time you repeat it, you can choose to make as many A's or B's as you want, right? So by unwrapping this outer star, you can see that you can basically create any number of alternations between A and B. So essentially that means it's going to generate the same language as A or B star.